Cool.
There you go. Sorry about that.
Thank you. Let's see. I will share my window. And here we go. Just to make sure you are all of you seeing the slides?
Yes.
Cool. So yeah, welcome to my talk today. I'm going to talk about Firebase and how to use it. Backend as a service, how to use Firebase as a backend service, basically. And as it was said before, I'm a software engineer at Google on Firebase, and let's dive in. Actually, before we dive in, I have some questions. How many of you have built an app with a backend? Feel free to raise your hand on Zoom or raise your hand physically. What are some difficulties you've encountered when you're building out these backend systems? Feel free to shout them out or type into the chat.
We will read it out loud, no worries.
All right, I guess I will continue on. I guess I'll talk about some difficulties I have when I'm building apps. Okay, so it's a complexity of communication between part of apps. Anyway, as I was saying, I'll also share some of my difficulties and challenges. So a lot of times when I'm building an app, I need a login system. But how do I do that? How do I make sure it's secure? I'll also generally need a place to store data. Which database should I use? There's a lot of options out there. And also likely need to store profile pictures and some other static content. I also realized that.
Yeah, Andrea, we're seeing your wrong screen. We want to see your presentation as opposed to you. We like you, of course. Yeah.
Oh, I just have to tap back. There we go.
There you go. That's it. Perfect.
Oops. Okay. So as I was saying, I also need a place to store data, but what database should I use? There's a lot of options out there, and I also likely need to store profile pictures and maybe some other static content. Where should I do that? And I don't really want to build my own authentication, database, or storage solution because it's a lot of work, and it's all work that doesn't really have to do with my app. There's a lot of groundwork that I need in order to build my app, but it's not the actual meaty part of my app. And after I finally build them, I'll have to maintain all those systems, and I have to onboard any new members onto those systems. So that means good documentation as well. Sounds like a lot of work. And again, none of this is really like core to my actual feature development for my app. This is just kind of the infrastructure and groundwork to get my app up and going. The good news is there's already some existing solutions for like auth or database or storage, but which one should I use? Do I have to install them all, learn them all? And personally, I also run into a lot of compatibility issues where some version of one software is incompatible with another technology's version, and that's not really that much fun to figure out. And all of this is pretty time consuming, and at the end, the code turns pretty messy and bloated with all the libraries, a lot of things to keep track of, and there's also a lot to learn at once. Some other concerns that come to mind is where I should host my app, and ultimately, I'd like a lot of people to use my app, so how do I scale? So this is a lot of questions. Backend is really hard, and as you may have guessed from the topic of this talk, Firebase can help with a lot of these backend issues. So what is Firebase? Firebase is Google's app development platform, and a lot of it is built on top of Google Cloud. And it also integrates with a lot of other Google tools like analytics and ads. And because it's built on Google infrastructure, it's designed to scale. So as an introduction of a deeper introduction of what Firebase is a suite of a lot of different products. And these are the categories we like to think about to make sense of all of Firebase's products. There's about 20 of them out there. So first and foremost, Firebase is intended to help developers through the life cycle of developing apps, which kind of typically goes like this. You have an idea and you want to build an app. And that app typically includes some backend. So these are some products that we have that can help with that initial building phase. So there's authentication, which I talked about a little bit earlier, which is a logging in system. There's Cloud Firestore and Real-Time Database, which are both NoSQL databases. There's cloud storage to help store big blobs of data like photos, videos, and audio content. And we also have hosting, which helps you put your website onto the internet. And there's also some other things that I didn't mention that also help with building out your app. So let's say you build your app, you use these backend services, and it makes your app development phase a lot faster. And you build it and you deploy it. Yay, launching is always fun. So after you do that, you can monitor how the app is doing in terms of performance by using Crashlytics and performance monitoring. And you can fix any quality bugs and use TestLab to test those fixes on different devices. So once that's done, maybe do a few iterations of that. Your app will probably reach a stable state, hopefully, and you'll probably think about how to grow your app to attract more users and also retain the users you already have. So these are some of the products that can help you do that. So this is a lot of products, but don't worry, we don't have to use all of them at once. The good thing about Firebase is we can kind of pick and choose what we want. And because there's so many products, there's probably something that will be helpful for you when you're kind of building out your app or trying to grow your app or trying to monitor your app. Cool. And also, just as a side note, Firebase was built with app developers in mind. This is a product for app developers. So when we use Firebase, we actually don't need to write a lot of code, which seems counterintuitive, but we wrote it that way so that, you know, as a user, we don't have to have so much code. So we also support a lot of different clients. So we have client-side SDKs for iOS, Swift, and Objective-C. We have Android for Java and Kotlin. We have web JavaScript, C++, Unity, Flutter, some frameworks like Angular and React Native. So these are all the platforms that Firebase can help support. All right, so now that we know kind of what Firebase is, let's talk about how we can use some of these products to build out a new app. So before we build out the actual app, let's introduce what we're trying to do here. So we're going to build an expense tracker. And as a person who really cares about how I'm spending my money, I really want to keep track of my expenses. And what I actually do right now, I know there's existing apps that do this, but anyway, I do this. I keep a spreadsheet of my expenses. I look at the receipt and manually enter the date, the vendor, the item bought, and the amount each time I spend money. And this is generally okay until this happens. Either I have a lot of expenses because I procrastinated and let my expenses pile up, or I went on a business trip and have a ton of expenses from the lifts and meals and flights and hotels and all those things. So it becomes pretty painful and tedious to kind of manually enter all of this data. In large quantities, it's just not really that great of an experience to have to manually input the date, the vendor, item, and amount for all of these receipts. So let's make an app to make all of this better. So instead of having to manually type in the expense data for all of those receipts, we're going to make an app to allow users to conveniently scan receipts, and the app will automatically extract the relevant information from those receipts. So this way, the app does all the work with just an uploaded receipt image, and then can send the extracted information to the user for some verification. So this means that the user no longer needs to do any manual work aside from taking a picture of the receipt and at the end confirming that the amount is correct. So let's define some app requirements. So we want users to be able to upload images either by taking a photo through their camera or by choosing an image that they already have on their phone. Then our app needs to find and extract the text, and we'll want to scan the receipt to parse for things like date, vendor, item bought, and the amount spent. And finally, we'll want to relay what we found back to the user because we need them to actually confirm the information we extracted. And hopefully we do a good job with the scanning and it's accurate, because if we did a bad job, then this isn't really much of a confirmation step anymore. It becomes a correction step, and the app is kind of useless because we built this in the first place to, eliminate the work that a user would have to do. So if it's wrong, then this app's not very helpful. So I want to make sure that the scanning is right and it reads the information correctly. Diving a little bit deeper into what we want our app to look like, here's some of the needs that we'll define. So we want to be able to securely upload our receipt images. We want to store these receipt images and extract the text. And we want to do some image processing based on the uploaded receipts. So this sounds pretty complicated, but let's see how we can do it. So the first thing we said we need is secure image upload, which pretty much means we need to have users and have users be able to sign in. I don't really want to build, I don't really want to spend a lot of hours building a logging system, like I said before, because it'd probably be pretty tricky to build it out and also really care about security, right? Security is a big part of authentication, and we want to get that correct. And also, as a user of a lot of apps myself, I know that I don't really like creating a new account for every single app that I use. It gets really repetitive to set up an account with my first name, last name, email, birthday, the name of the street I grew up on, and all the information they usually ask for. And then I have to remember my password for that specific app, which I probably won't be able to do because we supposedly use different passwords for all the millions of accounts that we have. So it'd be really nice to not need to create a new account to use this app. So we have Firebase authentication. Authentication provides identity as a service, meaning it lets you know who your user is. There's also a rules system that lets you grant or deny access to resources in other Firebase products like Firestore and storage. And Auth is also ready to use out of the box, and it gives some advanced functionalities like email verification and account linking. So regarding the concern about not wanting to create a new account, Firebase Auth also works with a lot of third-party identity providers, meaning you can log in with Google or Facebook, Twitter, GitHub, email, some other ones as well. And once these users sign in with one of these services, we assign that user a record within Firebase's system. And that record includes a unique user ID and a signed web token. So you get a consistent representation of your users. So one that you can use against Firebase's systems and one that you can use also with your own custom servers, regardless of how they choose to sign in. So let's take a quick look at what the code would look like if we wanted to allow our users to sign in with Google. So assuming we already created a Firebase project and injected all the correct Firebase dependencies, there's basically like one that says import Firebase, and for every product that you want to use for Firebase, there's one other dependency. So we can handle authentication with very few lines of code. Also, don't worry about copying this down. It's all in the Firebase documentation, as is the rest of the code that you'll see in this presentation today. So first, as shown here already on the screen, we need to create an instance of the Google provider object, which says we basically want to use Google to sign in. And if you wanted to use Facebook or Twitter or GitHub or something else, you could use those respective providers here. And next, we'll make the user actually authenticate. There's two ways to do this. We can either open a pop-up window or redirect them to a sign-in page. And what's shown here is signing in with a pop-up. And we can pass in the provider into that function call. Basically, what this is doing is it's saying use Firebase Auth to sign in with a pop-up using the Google provider. Once we do that, we can also handle the cases of the user being successfully signed in versus not. So this is how we can implement authentication using our third-party providers with just a few lines of code. Imagine if you had to build this by yourself, right? There's going to be more than like 3 lines of code. So this is a positive side of using Firebase. I've used Firebase kind of for my outside of work projects, and it's really, really simple. Thankfully, I don't have to build my own auth system here. So let's say we want to give users the option to create an account using usernames and passwords. So before we were talking about if we want to enable a user to log in with some other provider out there. And we want them to create an actual account with the app that I'm trying to build, then we could do it Firebase Auth can do that as well. So it'll securely store and encrypt this information while also taking care of necessary tasks like generating password reset emails when your users eventually forget their password. And if you don't want to force users to memorize yet another email and password, and they don't want to sign in with any of the third-party providers, Firebase Auth also has support for phone number authentication, which basically enables users to sign in simply by receiving a code through a text message. So there's a lot of ways that a user can create an account and sign in, basically. So let's see how we'd be able to make a user create an account with email and password, as well as how to check whether a user has already logged into the app. So to create a user with email and password, we'd first have to make some pages for the user to create an account. So let's say these are the pages that we have for the user to fill in a username and password. So assuming they fill that in, we can use Firebase authentication code to create an account. And this is what the code looks like. We'll call the create user with email and password function while passing in the typed in email and password from the screens from the last slide. And that'll result in either a successful creation of the account or it'll fail. And if it fails, we can handle the errors here. If it succeeds, we'll be able to see the user's new account in Firebase console. And I'll show you what that looks like. Just as a side note, Firebase console is a web portal to let you see what you've been doing with Firebase for a project. And in this case, we'll be able to see all the users who have logged into your app. So this is what Firebase console looks like. You don't automatically land on that page, but you'll click on your project and authentication is here on the left. So here we can see people who have logged in. This person used their email. You can see what provider they logged in with. Here's the email icon. You can see when they created their account, when they last signed in, which is blank here, and the unique user ID that you can use throughout your app for other Firebase products or any server that you want to create as well. Oh, so let's pretend the user had to log in again and they already have an account and wants to sign in. So let's say this is the screen for that. So upon pushing that submit button, we'll call the sign in with email and password function and pass in the email and password from the screen before. And this is going to either successfully sign them in or it'll fail. And if it fails, we can handle the error here. Now, let's talk about the succeeding case in the code for both creating a brand new account and when a user successfully signs in. To get the currently signed in user, we can set an observer on the auth object. Oh, by the way, this is all web, but we have documentation for other development platforms as well. So anytime the authentication state changes, this function is going to get triggered. And if there's a user, then the user signed in. Otherwise, no user signed in. So this function is going to return a user whenever create user with email and password and sign in with email and password get called successfully, and as well as with third-party providers. So once you have the user, you can also get various information about the user, like the display name, their email, their user ID, as shown here. So now that we've seen how to write a few lines of code to sign in, create an account, and check if a user is already logged into your app, this sounds like a much easier way than writing your own authentication system, right? Here's one last tidbit. Even though the code is already not a lot, it's still quite a bit of work to actually make these sign-in screens. So we want sign-in screens with multiple third parties, sign-in buttons, or a create new user screen, or screens to reset and change passwords. And if that's not where you want to spend your development time, we actually have a Firebase UI library, and it already handles all of these cases for you. So you can kind of plug that into your app, and you automatically have these pages. And it's an open source library, so you can customize it to the look and feel of your own app. So now that we've allowed users to sign in through some of these third-party identity providers or through creating an account using email, password, or text message, and we also know whether they're signed in or not, let's move on to our next step, which would be uploading receipts. So let's say we have a screen to allow the user to upload their receipt, either by taking a photo of it or by choosing a file that already exists. Once they do that and upload it, we should store it somewhere. What do we need from our storage system that's going to store these receipts? Well, we want it to be fast for uploading and viewing receipts from anywhere in the world. We also want it to work well even with spotty internet connections. And we might need to store a lot of receipts, and we don't have a bunch of people to keep an eye on usage and adjust our storage capacity. And lastly, we might have to consider working with a variety of image types. So cloud storage was designed with a lot of these concerns in mind. So it lets you store many image types. And on top of that, it lets you store and serve user-generated content like audio and video. It's generally used for storing big blobs of data that you're not going to need to change too often. And to store a lot of receipts, the amount of storage is going to scale automatically, which means that the storage space is going to increase if you have more content, if you add more things to storage, and it'll decrease as it removes content from storage. So you're not going to need someone sitting there manually managing the amount of space that your app needs for storage. And to be fast from anywhere around the world, cloud storage has a global edge cache, which means that if I just pulled up a receipt to look at, storage will store that in a nearby cache so that if I want to see the same receipt again 5 minutes later, I'll be able to get that image pretty quickly. Sometimes, like I was saying before, internet connection isn't that great. And we wouldn't want my receipt to be half uploaded and then dropped because my internet was spotty. Luckily, storage takes care of this and handles retrying and resuming uploads and syncs whenever my phone gets back on the internet. And after my receipt is loaded, it can be shared with other users instantly. So this means that if for whatever reason my parents want to look at my receipts, they can look at it right after I upload it to Firebase. On the other hand, I don't really want to just let anyone be able to see my receipts. So there are security rules I can set to protect it using auth that we talked about earlier. So these rules can say who is allowed to read and write certain files in the cloud storage that I have. So let's take a quick look at some code to upload files. So we have a file we want to upload. Firebase storage supports files from JavaScript file and blob APIs, bytes, strings, base64 formatted strings, base64 URLs, and data URL strings. And this shows where we're going to store it. So let's grab our storage bucket and we'll create a root reference. And from there, we can create a child reference to the full path of the file with the file name. So now with our reference, we can then upload it to cloud storage by calling the put method on the reference. And just by doing like 4 lines of code, the file will get uploaded to storage and we can post-process anything we need to after it does so. So in our case with the expense tracker, we'd get the file selected by the user using the JavaScript file API and upload it accordingly to storage using this code. So great, now we've uploaded our receipts into storage. Next, we'll probably want to run some code to process that receipt, but we may not want to do all the processing on the client side, which would be a phone. Why not? Well, once we write our top secret code to process those receipts, we don't want anyone to just be able to take it along with the data. Requests coming in from users' phones might be trying to steal it, and we really don't want that to happen. We need something to help us with running code against our data securely. We might also want both iOS and Android users to be able to use our app, but we might not want to duplicate code to process those receipts twice. It'd be much better if we could write the code once and have the code run instead of writing it once for iOS and deploying to the App Store and writing it once for Android to deploy to the Play Store. Also, if we deploy the app separately, iOS users might get this awesome feature first and Android users might get mad, and we definitely don't want that. And remember, we're going to process our receipts, and we mentioned that we'll need to run some tech recognition on the receipts, which we can imagine might be CPU intensive. The last thing we want to do is run highly intensive code off of our users' devices, especially if it might drain a user's battery. So if we do that, a user's phone might run out of battery a lot faster, and we don't want to do that either. So Cloud Functions can let us run code in the cloud, and it's a secure environment, and you can write it just once for both iOS and Android. So to run the code, you can trigger it based on platform events or a HTTP request on both platforms. And since it's running on the cloud off of the user's device, this isn't going to be hard on their devices. So basically, you can run backend code without managing any servers. So we know we're going to use functions to run our processing, but what are our functions actually going to do? Well, we need some machine learning to help us extract the numbers from the receipt, also known as optical character recognition or OCR. And we want to get this automatically done, but I don't really know how to do machine learning. Machine learning is not a trivial task, and usually a team will need a data scientist or a machine learning expert to build and train these models. And in order to serve these models dynamically, we'd have to build up the infrastructure to do that. And that's before we even write the client code to interact with the model and generate predictions. So this sounds like a really involved and long task, which it usually is. So we have Firebase machine learning to help us do some of this stuff. What is it? We take some of Google's machine learning models to help with different machine learning capabilities, depending on what features we're looking for to add to an app. So it can recognize text or barcodes from an image. It can translate text to a different language or identify important objects in a photo. And no machine learning experience is needed. We just need to call Google Cloud Vision and natural language APIs in our app, and we'll be ready to go. And a lot of these libraries are pretty useful in a lot of situations, but what can we do if we have machine learning needs that don't fall into one of these categories? Well, Firebase machine learning has custom model serving and auto ML vision edge that makes it easy for us to create and deploy custom machine learning solutions to our users' devices. So for our OCR app, we are going to use text recognition. So now we've used some machine learning to extract text from the uploaded receipts. What's next? After we got the text back, we need to put it somewhere in a secure environment. There's probably going to be a lot of extracted text, and we want this text to be quickly accessed from anywhere in the world. Where should we put it? Let's put it in Cloud Firestore. As a reminder, earlier we talked about storage, which is used to store the receipt images. So storage is usually used to store big chunks of data like images, audio, and video, whereas Cloud Firestore is a NoSQL database where you can store data like strings, numbers, and whatever your app requires. Firestore is used more for structured data that you might need to change often. So while our receipt images are stored in Firebase storage, the processed text that we get back from Firebase machine learning is going to be stored in Firestore. So very similar to storage, Firestore integrates with Firebase auth and security rules so that clients can talk to the database directly, but you can still make sure that they get access to the documents they're supposed to see or modify and that nobody else can access that information. So let's dive a bit deeper on how Cloud Firestore is structured and how we can use it. It's a document model database, which means that all of the data is stored in documents and collections. And you can think of a document as something like a dictionary or a hash table. So it has a set of key value pairs, which we refer to as fields. And the values here can be a number of different types, anything from strings to numbers to binary values to JSON-y looking objects called maps. So we have the document containing the fields we saw in the previous slide, and each of these documents is stored in a collection. Documents cannot contain other documents, but they can point to collections that contain other documents, which can point to other sub-collections, and so on. So in our example, each document will contain information from one uploaded receipt. So here are some examples of what that might look like. Each receipt document contains some values, including the date, the amount, the vendor, the item, and whether the user has verified these details yet. And all of these will go into a collection for one user. With code, it will look something like this. First, we'll get our Firestore instance, and then we'll make a collection on it. Since we're making a collection per user, we'll want to identify each user. How should we do that? Well, since we used Firebase auth earlier, and that returns a token that uniquely identifies each user, we can just use that as the name to identify each user's collection. To create a document, we need to use the add method. What are we adding in this case? Well, we want to add the key value pairs that we see in this receipt. When the document is successfully added, we can do something with that. And when there's an error, we can handle it as well. In Firebase Firestore, this is what it's going to look like. So let's go to Firestore. So as you can see here, here's the token name. Here's the token from authentication. And the document name is a random string made up by Firestore. So I didn't really type this in anywhere. It just automatically happens when we call add. I'll talk about a case where we might actually want to name that. But for now, let's see inside of the document, we can see all the fields that we put in. So this is basically our database. So we can see the amount, the date, item, vendor, and whether the user has verified the amount. So now that we have the extracted text for our expense tracking app in our database, how do we get that data out of the database in order to send to the user to ask them to verify the amount? Well, we can use the get function to get all the documents within our collection. We can then loop through each of the documents and send the information to the user to verify. All right, so now, as I mentioned before, we didn't really care about what each document was called, so we let Firebase set a random string for each receipt document. Let's pretend for a moment that instead of tracking each receipt, we are using this app to track an entire family's expenses. We want to track the total cost a family has spent in a year, but we don't really care about each specific receipt amount. So in this case, we'll create a collection of total costs, and each document will be for each family member containing information about when they last spent and the total amount they've spent this year. So like before, we'll make a db.collection, but this time with name cost. We'll also have a document for each family member who is using this app. So each family member will have their own unique auth token. We can set the document to be identified with that unique auth token, and then we'll use the set function, which pretty much does the same thing as the add function we used before, except that it uses the name you specified here. And like before, when the document is successfully added or edited, we can do something with that. And if there's an error, we can handle it as well. So in Firebase Firestore, this is what it looks like. So here we can see that we have each family member's document here. We have the amount that they've spent this year so far, as well as when it was last updated. We have one for dad and one for mom. So let's see how we can get that amount. Like before, we'll find the cost collection and the doc with my auth token. And we'll use the get function just like last time. But instead of getting all of the documents, we'll only have to get one particular document for one particular family member since we specified the document. So if getting it is successful and it doesn't error, we first check whether the doc exists and pass that data along if so. And if not, we'll log that there's no document. And if getting the document errors, we'll also log it as such. Also, as a side note, in Firebase, we actually have two database products. One of them is Cloud Firestore, which we just talked about, and the other one is Real-Time Database, which is the older database product. Cloud Firestore is generally a better option unless you need to structure your data in a JSON tree instead, which is generally better for structuring data from your views. The link here describes more differences between the two, but if you're not very sure, generally speaking, people would use Cloud Firestore. Great, so now that we've extracted text by deploying functions that runs our text recognition and machine learning, and finally stores that in Firestore, what comes next? Well, we want to notify our users that we have their values, and we'll ask them to confirm. How do we do that? Let's send a push notification by using Firebase Cloud Messaging to tell users to confirm their receipt amounts. So Firebase Cloud Messaging is scalable, and it can deliver hundreds of billions of messages per day, with most of them delivered in less than 200 milliseconds. our users trying to upload receipts probably all use different types of phones, and we probably don't want to invent our own notification system for each phone. Thankfully, cloud messaging can deliver notifications to anyone using Android, iOS, and the web. And it doesn't need us to track what kind of devices our users are using. And we also don't need to set up different service calls to different devices. Firebase will just automatically send these notifications for us. And lastly, we're not only limited to using this to remind users to confirm their receipt amounts, we can also announce new features we're launching. For other apps that isn't this expense tracker we're talking about today, we can notify users for things like letting them know their last message was responded to, sending out discount offers, and reminders about events. So now we have notified our user to confirm their receipt amount. We'll store this response back into Firestore. And now we've basically built our app out. And let's say we built it out and it's sitting on our laptop or perhaps on GitHub. If we built this using mobile, like for Android or iOS, which is most likely what we built this on top of, we'd eventually figure out how to put it on the Play Store or the App Store. If we built this on the web, we can use Firebase hosting to help us get it off our laptop and actually deploy it onto a website for people to use. So let's talk a bit about Firebase hosting. First and foremost, it's a pretty easy way to host web apps. All we have to do is install the Firebase command line tool and write a single command, Firebase deploy. From there, Firebase hosting provisions a HTTPS certification, which guarantees security, and it deploys their assets to an origin server that will serve your content through a global CDN. And if for any case you want to roll back your app, you can basically go to Firebase console and roll back from there with just one click of a button. As I mentioned earlier, Firebase hosting has a global CDN, which stands for Content Distributed Network. And this means that there's a distributed set of servers holding our content. So whenever someone pulls up a page, the content is retrieved from a location as close to the user as possible. So for example, if we didn't have a global CDN and only had one server in the US, someone halfway across the world trying to access our website might have to wait a bit for the page to load, which isn't really a great experience. With a global CDN, we have another server closer to the user, so accessing our website will be faster because the place to get the content from is physically closer. Sometimes we're going to have to update our website after having deployed it once before, whether it's because we changed some content, added some features, or some other reason. When we do this update and redeploy to Firebase hosting, it's atomic, meaning that all of the servers around the world get updated with our new website and all the caches get purged. This pretty much means that the user is guaranteed to get the latest version of our app. Lastly, the heart of Firebase hosting is static, which means you're not using a backend system with your code, and typically means pure front-end JavaScript, HTML, CSS, or any of the front-end frameworks like Angular, React, and Vue. And if you're using frameworks like Django or Node, then the app is dynamic. So for dynamic sites, we can combine Firebase hosting with Cloud Functions to run our backend code and then generate content on the server. And when a user makes a request to our hosting URL, we can proxy it to our Cloud Functions along with all the request information. Cloud Functions can then do whatever processing it needs to do, grab assets from storage and data from Firestore, and then return all the information back to hosting in HTML. Hosting can then serve it back to the user. Or if you don't want to use Cloud Functions with hosting for dynamic sites, you can use one of Google Cloud's products called Google App Engine to host these dynamic sites. So there we have it. Our app is pretty much built. We successfully built an app from beginning to end with full functionality. We enable our users to log in using authentication, upload receipt images, which get stored in storage, trigger functions to do OCR using Firebase machine learning to extract details from the receipts, which then get stored in our Firestore database. And then we'll run some more functions based on values being written into Firestore to automatically send a cloud message to a user to have them confirm the receipt amount. And we even put it up on a website so people can start using this app immediately. And we didn't really have to write very much code to build out these systems, yeah, here we are. These are pretty much all of the Firebase products that can help you build an app. This is all backend related infrastructure. And cloud messaging is actually typically used to help you grow your app, not really part of building an app, but I tossed in that as a bonus. So that's it. We have built our app, and awesome. So here's some resources for the materials I covered today. The first one is a link to our Firebase website, and there you can see an overview of all of our products in detail. Each product has a lot of documentation and guides to get you through that particular product. And as I mentioned before, all of the code I showed today is on our documentation somewhere. The second link here is our official Firebase YouTube channel, where we show and step you through different Firebase use cases and help you with specific products. And lastly, you can always use your favorite search engine to find more information about Firebase, as it's a pretty well-supported community. Thank you all for attending, and happy coding. If there's any questions, I'm happy to answer them.
Oh, that was great, Andrea. Thanks. Hey, if you have a question, please drop it in the chat. Yeah, that was really terrific. The question I have is, not everybody here is a brilliant coder. The code seemed pretty simple, but while it seems pretty simple, can it be done in any language, or what? I saw you were doing it in Java, right?
Yeah, I was thinking in JavaScript. I can share the slide again for the different platforms we support. Mm-hmm. Let me share my screen again.
Oh, yeah, very good. Right. I heard you mention TypeScript, and yeah, that's great. Cool. Any other questions for Andrea? I found this to be really interesting. While my students do use Firebase, I didn't have a full knowledge like I do now. That was really terrific, Andrea. Thank you.
Awesome. Good to hear.
I'm impressed to see such a rounded experience.